Hello, in this video we will examine how students can use ClassWiz to support their understanding of sequences and series, and especially arithmetic sequences and series. I've turned on my ClassWiz, let's set it up. We'll start using Calculate mode in this video, so choose this mode with Menu and number 1. A key capability of ClassWiz is that it can be used to generate the terms of a sequence or a series automatically, both recursively and explicitly, so that it allows students to explore particular examples in depth. Recursion is involved when each term of the sequence is obtained from the previous term of the sequence in some way. To see how this works, let's generate a sequence starting with 5. Tap 5 and just tap equals. If the next term of the sequence is obtained by adding 7 to the previous term, just tap Add 7 into the calculator. Notice that the screen shows Answer Add 7 because ClassWiz assumes the 7 is added to the previous answer. Of course, when you tap equals, the result is 12. 5 and 7 are 12, the second term in the sequence. Now to repeat the same operation, that is to add 7 to the previous answer, tap equals again with no instruction added, so the same command will happen. That's 7 more. And if we tap it several times, we can see successive terms of the sequence are generated. So as you can see, the ClassWiz has a built-in recursion procedure. This idea is not restricted to addition. For example, a similar process can be used for subtraction or for multiplication. For example, think about this sequence. The first term is 12, and each term after that is 10.4% more than the previous term. Well, we start with 12, and after that we need to get 10% of the previous term added on. So that's multiplied by 1.104. That's 10.4% more. And tap equals. So the second term is 13.248. To get the third term, we simply press equals again, as you can see, and a single tap of the equals key will produce the next term, and so on. So successive terms can be generated with a single tap of the equals key, which is just using this same command again and again. More sophisticated and complicated recursive relationships can also be used to generate a sequence on ClassWiz. For example, suppose each term of the sequence is the previous term multiplied by 1 more than itself. So if the first term was 2, the second term would be 2 times 2 add 1, which is 2 3s are 6. The third term would be 6 times 6 add 1, which is 6 7s are 42. The fourth term would be 42 times 43, which is 1,806, and so on. So on ClassWiz, we've started with the first term, which is 2. To get the next term, we would multiply the previous term by 1 more than the previous term, like so. And you can see that I've used the answer key down on the bottom of the ClassWiz to get the previous answer. Previously it came up automatically, and now we have used it. So you can enter this expression, and we should expect the first one to be 2 times 3, which is 6. The next term, when we just tap the equals key to do the same thing again, we'll get 6 times 7, which is 42. And the next time will be 42 times 43, which is 1,806, and so on. Each tap of the equals key generates another term. Now, another way of defining sequences is with an explicit definition, which gives the value of the term as a function of its number in the sequence. So an example might be following. Each term of the sequence is the square of the term number. The best way to look at a sequence with this kind of definition is to use a table. So we'll choose menu and go down to table number 9 and enter an appropriate formula to generate the terms in this way. In this case, you remember the table can only use x as the variable, and so the term each time is the square of x. X stands for the term, and x squared gives the value of the sequence for that term. And we'll generate some examples, say from a value of 1, the first term, right through to, say, the 12th term in steps of 1. And when we press equals another time, here we have the table. First term is 1, the second term is 2 2s are 4, the third term is 3 3s are 9, the fourth term is 4 4s are 16, and so on. So the x value gives the sequence number, and the f at x value gives the term of the sequence. And we can see that the fifth term in this case is 25. We can get later terms by changing x. So for example, we can change x to 50 and see that the 50th term is 2,500. Now let's look at arithmetic sequences in particular. These are often the first sequences students study in school, because arithmetic sequences have a common difference between terms. They can be generated recursively on ClassWiz with an addition operation. So move back to calculate mode with menu and number 1, and we'll consider an elementary example to show the idea. Let's think of an arithmetic sequence with first term 8 and with common difference 3. So we start by putting the 8 in the calculator, that's the first term, and the common difference means each term is 3 more than the previous one, so the recursive process to generate the terms is add 3 each time, and the second term we can see is 11, and then the third term will be 14. If we wanted the sixth term, we need to do that 3 more times, 2, 3, so the sixth term is 23. The students would need to keep track of how many times they'd tap the equals sign to get a particular term. Now notice the successive terms of the sequence can actually be retrieved by scrolling upwards. Notice in the top of the screen here, there's a small arrow. If we go up now, the arrow indicates that there's material up there. So here's the 8, and now the arrow is pointing down. 8, 11, 14, 17, 20, and 23. So when we're scrolling, you can see the arrow sometimes says we can go up or down, and at the moment we can only go up. Generating the terms of an arithmetic sequence like this is a good strategy, as it reminds students of the nature of the sequence, and it can be used to answer many questions that deal with the early terms of the sequence. Questions like these: what's the 8th term of this sequence? Which term of the sequence is 17? We've got the 6th term there. To get the 8th term, we need to simply do that 2 more times and see the 8th term is 29. And which term of the sequence is 17? We can scroll up here, back to the start, and the first term was 8. There's the second term, the third term, the fourth term is 17. Now, of course, students will be expected to have a more sophisticated approach to sequences at some stage, possibly with an explicit formula to find the nth term of the sequence. A typical formula would be one like this. The first term is A, and n subtract 1 for the nth term times d, the common difference. A formula like this will be sensible to students who've started with the first term and added in n subtract 1 further terms by tapping the equal sign n subtract 1 times. It's not just a formula, it will have some meaning. Of course, we can tabulate a formula like this using x instead of n, both to see that it generates the same terms and also to answer questions with later terms of the sequence. Let's see how to do that. Menu and number 9 in table mode. And so the formula in this case is the first term is 8 and the n minus 1 will be in this case x subtract 1 times 3. First term is 8 and the common difference is 3. And we'll tap equals, equals. Let's generate the first 25 terms of the sequence, starting at 1, go through to 25 in steps of 1. And now the table will show 8, 11, 14, 17, as we saw before. And if we want to find a later term of the sequence, we can simply change the value of x. What's the 100th term of this sequence? I'll change that 10 to 100. The 100th term of the sequence is 305. So other typical school problems can be explored by using a table like this, giving students a good feel for the nature of an arithmetic sequence. Let's now think about an arithmetic series, which involves adding successive terms of an arithmetic sequence. Again, let's look at a particular example, starting with an arithmetic sequence with first term 4 and common difference 5. That's what each term of the sequence would be expressed as. First term is 4 and the common difference is 5. So we can generate each term of the sequence in the same way as before in calculate mode. Returning to calculate mode here, we could start with 4 and add 5 again and again and again. We can see the first few terms of the sequence recursively in the same way that we did before. 4, 9, 14, 29, in fact we can go back and see them here. 4, 9, 14, 19, 29. The series is the sum of the successive terms. 4 and then 4 and 9 are 13, and then 4 and 9 and 14 is 27, and 4 and 9 and 14 and 19 is 46, and so on. ClassWiz has a special command for evaluating a certain number of terms of a series using the sigma notation, which students will already be familiar with. It's over here on the calculator. So let's enter the expression for sigma notation, and we need to enter the general term using x. The general term is the one we have here. So 4 add x subtract 1 times 5. That's the general term. We're using the arrow now to move to the other parts of the expression. X is equal to 0. What's the first term we want? So let's start with 1, and we use the arrow again up to the top here, and let's get the sum of the first 10 terms of this sequence up there. And there we go. So if we wanted the sum of a different number of terms, we would need to edit the formula. Now this expression is a bit awkward, and it can be simplified, of course, using a little bit of algebra. You think about that expression, we could rearrange it this way. And so let's edit the formula to put in an easier expression. I'm just using the back key here. You can see I can delete what's here, the easiest way, and simply replace it with 5x subtract 1, which has the same meaning. And we'll just check we get the same result, and indeed we do. So if you wanted to find the sum of the first 100 terms of this sequence, just use the edit key, and here I've gone back to this point. I'm going to add another 0. Instead of 10, we'll have 100, and tap the equals key, and the ClassWiz will generate the result. If we wanted to add the sum of the terms from the 50th to the 100th, I'm just editing here, 100 is what we want, but down here we don't want 1, we want 50. I'm just editing it again. and tap equals, and the result is 19,074. Another approach to sequences and series is to use a spreadsheet in which you can generate the sequence and then add the successive terms to get the corresponding series. So let's use the same sequence to illustrate this with the spreadsheet. Tap menu, and the spreadsheet command is over here in number 8. So we have a new spreadsheet. We'll generate the sequence in the first column. So in this case, we're going to start with 4. And over here, I'm going to put in cell D1, I'm going to put the common difference, which is 5, in the case of the sequence that we were looking at earlier. Now, to generate the sequence itself, we need to use a fill formula, as before. So a fill formula is option and number 1. And the formula in this case is to start with cell A1 and then add the value in D1, which is the common difference. We want it to be an absolute value, so we need to choose the $, alpha and D, and $, again, and number 1. So that's a command using an absolute address as well as a relative address. And let's make the first 30 terms, like so. To generate the series, we use column B. Firstly, we'll put A1 into B1 using a formula. Now, using the equals command, and then A1, because the first term of the series is the same as the first term of the sequence. Now, starting in B2, we need a fill formula to generate the series. So option and number 1, the fill formula. And the next term of the series is the existing series, the series so far, which is B1. Add the next term of the sequence, A2. So each term of the series is the previous result of the series added the next term of the sequence. And let's again just go down to the first 20 terms, like so. And now when we tap equals, we can see how this has worked. Notice that the first term here is the same. 13 is 4 added to 9. 27 is 13 and 14 more. 46 is 27 and 19 more, and so on. So now we have a spreadsheet to investigate arithmetic series and arithmetic sequences. To investigate a different series, all we need to do is change the first term in A1. So we could change this to be 7, for example. And we could also change the common difference. In D1, we might make that 11, for example. So here we have a different sequence, starting with 7 with a common difference of 11, as you can see going down there. And here is the series. The first term is 7, the next one is 7, add 18, 29 more makes it 54, 40 more makes it 94, and so on. Finally, although a spreadsheet is very powerful, it's best to let students build it for themselves rather than merely showing it to them, so that they can understand the underlying structure of arithmetic sequences and series. Well, that's the end of our adventures with sequences and series. You'll find Module 14 of the ClassWiz book also contains information on sequences and series on ClassWiz, as well as detailed explanatory text, which can be copied for students as well as teachers. The module includes some exercises to check efficient ClassWiz use, some examples of activities to suggest educationally valuable things to do, and some guidance for teachers. You can download this book freely from the Casio Worldwide Education website. Happy calculating!